are inscribed angles, specifically the inscribed angle theorem and application. We've seen some of this before, but let's go through it quickly. We got points A and C are on the circle O. They ask us to draw point B on the circle so that AB is the diameter. Okay, so then draw angle ABC. So we need to go ahead and draw another line there. Which angle in your diagram is inscribed? That's a good question. So we know that because it's right here, angle ABC is inscribed. Which angle in your diagram is the central angle? That's angle, well, we got a couple of them, don't we? We got angle AOC or angle BOC, which is the intercepted arc. Intercepted arc is right here. AC, which is the intercepted arc of angle AOC. It is also AC, and I didn't finish answering the question up here for D. It says intercepted arc of ABC. They end up being one and the same, interestingly enough. The measure of the inscribed angle ACD is X. ACD is X. And the measure of the central angle is Y. Find measure of CAB. They're asking us to find that angle there. That's interesting. Now I know that because all radii are congruent, that's an isosceles triangle. And if the legs are congruent, then the base angles are congruent, so that's also X. Now you've got two ways of figuring this out. One is to say that there's an exterior angle theorem that says that this angle here is equal to the two remote interior angles. So that's got to be 2x. Or we know that those two angles are supplementary, so 180 degrees minus y. So you've got two ways of looking at that and defining that angle. All right, so they're walking us through a longer process here, which I think can be interesting. We're going to take some of these as they are, but I think really what they're asking us to do is just play with this and see what we notice. Okay, so A and C are points on the circle O. What is the intercepted arc of angle COA? Well, you got clearly AC is the intercepted arc. Then they ask us to draw a triangle AOC. So again, we're going to draw that in here like so. And what type of triangle is this? Well, we know this is an isosceles triangle because we know all radii are congruent. All are congruent. What can you conclude about measure of angle OCA and OAC? Well, we also know that these are congruent because if the legs are congruent, then the base angles are congruent. They said draw a point B on the circle O, that is in the interior of the inscribed angle ABC. So that O is in the end. So what we're trying to do is we're going to do this. This is point B here. And we're asked to draw this in here. And I probably should have used a different color, but we'll survive. Okay. What is the intercepted arc of ABC? Well, that's also AC. I'm not using different colors, but I should have. What do you notice about AC? In terms of the arc, we know that the central angle and the inscribed angle both intercept the same arc here. It says, let the measure of angle ABC be X and the measure of AOC be Y. Prove. And then they said, hint, draw a diameter that contains the point B. Wow. So they're saying ABC, if this is X and this is Y, right? Prove that Y is equal to twice the value of X. And they said, hint, draw the diameter that contains B. So if we do that, let's do this. From here, that's got to go through the center here. Okay, now that's interesting because does that matter really where that is? In terms of the proof, we know that we can create triangles here of some sort, but I think it's almost easier to look at this as a something that a live Desmos geometry. So let's take a look at that. Okay, so looking at this live means that we can manipulate this a little bit. And again, here's A, O, C. Notice that B doesn't matter where it is. It doesn't even have to have O in the middle. That it is half of AOC. And again, like I said, we can go through a proof, but I'm not sure that at this point that that's needed. It's a pretty cool relationship that no matter where it's at, the inscribed angle is half the central angle. All right, so let's keep going. And we're going to skip this for time's sake. Let's take a look at some problems. Find the measure of the angle with measure X. Diagrams are not drawn to scale, so don't trust the look of it. We know that D here is 25, right? And if that's half the central angle, then X has to equal 50. If D equals 15, we know this then is 15 because those two angles, the legs are congruent, makes an isosceles triangle. So X has to be 15. We're given a right angle here, which means that it intercepts this arc. Notice that this angle, this inscribed angle, intercepts the same arc. So X has to be half of 90, or X equals 45 degrees. Measure of angle B is 32. Therefore, this is 64. We know that's an isosceles triangle. We know that x plus 64 equals 180. So therefore, 2x equals 116, or x, when you divide by 2, gives me 58 degrees. BD and AB are congruent. BD and AB. Well, AB is a radius, which means all of these are congruent, right? Notice that now I have an equilateral triangle, which means that x has to equal 60 degrees. Angle D is 19 degrees. Notice that it intercepts this arc. The inscribed angle is going to be half the intercepted arc. I'm sorry, well, that's true, but we're not there yet. It's going to be half the central angle. That means this is 38. These are radii or congruents. That means this is also x. So we know x plus 38 equals 180. 2x equals 142. X therefore equals 71 degrees. And let's just keep going.